What's up, you friggin' geniuses? So in this video, I'm going to teach you how to find trig values using Pythagorean identities. All right, so we're going to go over two examples, and we're going to start with this first one right here. So it says, let theta be an acute angle such that the sine of theta is equal to 0.6. Find the value of two values, right? So the cosine of theta and the tangent of theta using the trig identities, which are these three right here. Okay, so let's just start from the beginning, all right? Just with the first piece of information it tells us. It says that the sine of theta is equal to 0.6, all right? So let's just start there. The sine of theta is equal to 0.6. All right, so what can we do with this piece of information? Well, let's just start at the beginning, right? Let's use our trig ratios, right? SOHCAHTOA. So let's say SOHCAHTOA, or at least I'll say it, all right? So the sine of theta is equal to the opposite side over the hypotenuse, the cosine of theta is equal to the adjacent side over the hypotenuse, and the tangent of theta is equal to the opposite side over the adjacent side. Okay, so we're given the sine of theta, which would be this one, right? So the sine of theta is equal to the opposite side over the hypotenuse, right? So the sine of theta is equal to, well, it tells us it's equal to 0.6, but let's fill that in anyways. It's also equal to the opposite side over the hypotenuse. Okay, now, what two numbers can we plug in here that would be equal to 0.6? We can plug in literally any numbers that would work. So in this case, let's plug in a 0.6 on top. Right, 0.6, and 0.6 divided by, let's say 1, is equal to 0.6, right? So we just found two values for the opposite side of theta and the hypotenuse of this triangle that we're going to draw, all right? So now that we got a couple pieces of information here, let's draw a triangle. And then we'll label one of the sides, let's just label this side as theta, okay? Now, again, we got that the opposite side, we're going to say 0.6, so the opposite side of theta is going to be this side over here, right? So we'll say this is 0.6, and the hypotenuse is 1. All right, and then we don't know this side right here, so let's just label that as x for now. Okay, great. So now that we got a picture going on, what are we looking for? All right, so it says the first thing that we want to find, it says find the value of cosine of theta. So we want to find the cosine of theta, which we know is equal to the adjacent side over the hypotenuse, all right? So we need this adjacent side right here. So in order to find that, we're going to have to use one of our trig identities over here, the Pythagorean identities. And in this case, what would we want to use? So it's probably kind of obvious, but in this case, we would want to use the first one. And the reason for that is because we already know what sine of theta is, right? And we're looking for cosine of theta. So this first one is probably a good option. So here, let's just write down our identity. So we're going to say that the sine squared of theta plus the cosine squared theta is equal to 1. Okay, now the sine squared of theta is the same exact thing as the sine of theta squared, right? That's what this means. So what is sine of theta in our problem? Well, it told us from the very beginning, right? 0.6. So let's plug in a 0.6 right here for the sine of theta. So we're going to plug in a 0.6 right there. And then we're going to add, so we can rewrite it like this if you want, or just to make it a little bit more clear what we're doing, you can write it as the cosine of theta squared. And again, this is all equal to 1, all right? Now 0.6 squared, that's equal to 0.36, and we're going to say plus the cosine of theta, and this is squared, is equal to 1. All right, so we're looking for the cosine of theta, right? That's the first part. So here, in order to solve for cosine, let's get rid of the 0.36. So we're going to subtract 0.36 from both sides. So over here, they cancel out, and we're left with the cosine of theta squared is equal to, it looks like 0.64, right? 0.64. All right, now we're trying to solve for the cosine of theta, so we need to get rid of this exponent, and the way that we do that is by taking the square root of it. And again, what we do to one side, we do to the other, right? So we'll take the square root of this side as well, and then we'll scroll down, or I'll scroll down so you can see the rest of this problem. So then the square root and the squared exponent cancel each other out, and then we're just left with whatever's inside of that radical. So in this case, it's going to be the cosine of theta, which is conveniently what we're looking for. And that's going to be equal to the square root of 0.64, which is going to be equal to 0.8. All right, so there's our answer for part A. All right, we also now know what is the length of this missing side, x. Let's just fill that in now. Now we know that it's 0.8, right? So the original equation, sine squared theta plus cosine squared theta is equal to 1, was really 0.6 squared plus 0.8 squared is equal to 1. Okay, and that makes sense, right? Because if you think of just the regular Pythagorean theorem, right, that's a squared plus b squared is equal to c squared, where a and b are the two shorter sides of the triangle and c is the hypotenuse, right? So that's what we got here. We got a squared plus b squared is equal to c squared. All right, great. So that was part A. Now let's move on to part B, which is just finding the tangent of theta. So the tangent of theta, there's several ways we could find this, but one easy way we could do it is just remembering that the trig identity of tangent tells us that tangent is equal to sine over cosine, right? So the tangent of theta is equal to the sine of theta over the cosine of theta. So here we already know what sine of theta is, right? That was the first thing we were given. It's 0.6. And then what we just found right now, cosine of theta is equal to 0.8. So if you divide these two, you're going to get 0.75. All right, now let's just do this last one. So this one says, let theta be an acute angle such that the tangent of theta is equal to 1/3. Find the value of secant theta this time using the trig identities. All right, so first of all, we're given that the tangent of theta is equal to 1/3. So looking at our identities here, you can see this formula uses tangent. We're also asked to find the value of the secant of theta using the trig identities. And this formula also gives us secant, right? So this is probably the equation or formula that we're going to want to use. All right, so let's just write it over here. So we're going to want to use 1 plus the tangent square of theta is equal to secant squared theta. All right, so all we're given here is that the tangent of theta is equal to 1/3. All right, so let's plug that in for our tangent value. So again, we can rewrite this a little bit to make it a little more clear what we're actually plugging in, right? So we can rewrite this as 1 plus the tangent of theta squared. And that's equal to the secant of theta squared, right? That's, again, another way we can rewrite it. So now we can see what we're going to plug in for the tangent of theta, right? We're going to plug in 1/3 right here. So we're going to have plus 1/3 squared is equal to secant of theta squared, all right? Here, let's simplify this. So 1/3 squared, that's the same thing as 1/3, and then this exponent, the way you apply it to a fraction is you apply it to the top and to the bottom, right? So then on top we have 1 squared, on the bottom we have 3 squared, so this is equal to 1/9, right? So let's just erase this and simplify that right now. Let's just write it as 1/9. And again, that's equal to the secant of theta squared. So then here we have 1 plus 1/9, which is equal to 1 and 1/9. And we can turn that into an improper fraction, which will be a little bit easier to work with. So let's multiply these two together. So 9 times 1 is 9, and 9 plus 1 is 10. So this is equal to 10/9. All right, so this thing is equal to 10/9. And then again, that's equal to the secant of theta squared. All right, so again, we're trying to solve for the secant of theta. So now we can get rid of this exponent to 2. And again, we can do that by taking the square root of both sides. Over here, they cancel out. So we're simply left with the secant of theta is equal to the square root of 10/9. And let's just do that over here. So the square root of 10/9 is the same thing as the square root of 10 over the square root of 9. All right, you can basically just split it up into the numerator and denominator. And so then this is going to be equal to the square root of 10 over 3, right? So then here we get the square root of 10 over 3. So that's what secant of theta is equal to. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.